Welcome to my Kcse Mathematics Revision channel. Teacher James Marita. Kindly subscribe my channel, watch and share. We are looking at Kcse past questions on longitude and latitude. There is a question here of Kcse 1989. Kcse 1989, there was this question. A globe representing the Earth as a radius of 0.5 meters. So there is a globe representing the Earth as a radius of 0.5 meters. We have points A, which is 0 degrees. Then we have 10 degrees west. It is at the equator. 0 degrees is at the equator. Then we have point B, which is at 0 degrees, 35 degrees east. So you can realize that the 2 points, they lie on the equator. So they lie on the equator. We have A, which is at 10 degrees west, and then we have P, which is at 35 degrees east. So find and then we have point P, which is 60 degrees north, and then we have 110 degrees east. And we have point Q, which is 60 degrees north, 120 degrees west. What did you realize here? That P and Q, they share a common latitude of 60 degrees north. So from the equator, at the equator we have point A and P. So when you move to north, the globe becomes smaller. And then in that case now, we have another 2 points from the equator, which is at 60 degrees north. One is at 120 degrees west, and the other one is 110 degrees east. So find the length of the arc AP, leaving your answer in terms of pi. So what do we do here? We can represent the equator, the 2 points here. At the equator, we have 2 points at the equator here. So we have these 2 points here. At the equator, this is the equator, which is 0 degrees. This is the equator, 0 degrees. The equator, 0 degrees. Then I will have a prime, a Greenwich meridian here, which is 0 degrees. So this is the equator. Then we have a Greenwich meridian. Then we have the point from 0 degrees, we have 35 degrees east. So from here along that equator, we have this is a 35 degrees east. This is where we have our point P. Then from 0 degrees here, remember this is a Greenwich meridian, and this is the equator. So we have these 2 points here and here along this equator. Here, 0 degrees to 35 degrees east, we have point P. 0 degrees to 10 degrees west, we have point A. So this is our 10 degrees here, west, and this is where we have our point. We have our point A here. So we are supposed to find the length of the arc. So this one here is 10 degrees. This one here is 35 degrees. So we are supposed to have the longitude difference. Longitude difference is equal to be 10 degrees west plus 35 degrees east, and this one is giving us 45 degrees. The arc length, formula of getting the arc length is equal to P, the angle between over 360 times 2 times pi times r. So we are talking about times this r here. So what did you have there? Remember, we are supposed to leave our answer in terms of pi. So this r is not the radius of the arc, which is equivalent to 63 70. Don't use that one. because we have been given that the radius is here. The radius is 0.5. So our angle is 45 all over 360 times 2 times pi. So pi remains because we are supposed to leave our hands in terms of pi, 10 times the radius, which is 0.5. And this one here is equivalent to 0.125 pi. 0.125 pi. Or you can also get this one in terms of 1 all over 8 pi, like that. So that is how you get the length of the arc, AP. Leave your answer in terms of pi. So if O is the center of the latitude 60 degrees north, find the area of the minor sector. If O is the center of the latitude 60 degrees north, find the area of the minor sector. So we can have that latitude. This is a latitude of 60 degrees north. This is 60 degrees north, a latitude of 60 degrees north. We have a Greenwich meridian here. From 0 degrees, there is a point at the east, which is 110. So we have this is 110 degrees east. Then there is 120 degrees west. So we have this is 120 degrees west. So we need to have the angle here between, which is 120 plus 110. That one is giving us 230. So this one here we have this is 230 degrees. Then we have the area of the minor sector. The minor sector is here, so we need this angle. We need this angle here. So that angle theta is equivalent to the 360 degrees minus 230, and this one is giving 130 degrees. So how do you get the area of our sector? But there is the radius. So area of our sector equals to the theta all over 360 times pi, in that case a radius squared. So do we have that radius? Our r is equal to the, from here, remember this one is 0.5, and we are moving from the equator. Onwards. So we are moving from the equator. So as we move from the equator towards southwest or south, the globe becomes smaller. So that radius is the radius of the earth. Then we have cos theta. You can talk of this. You can say that one as r cos theta or r cos alpha, where this one is equal to. So that radius is equal to the r. Then we talk of cos 60. R is 6370, so it is 6370 10 times cos 60, and this one you can get, if you can substitute that one, you can get a 0.25. This one will give us 0.25. So our area of that sector is equal to the theta. Our theta is 130 degrees all over 360 times now I is 22 all over 7 times the radius 0.25 times 0.25, and the area of that sector will be equivalent to be 0.0709, in that case meters squared.